For solving long division using the drag down method or working from left to right, the first thing I want to do is list the multiples of the number I'm dividing by. I'm going to answer 3 questions in the next video. 12,043 divided by 37, 1,652 divided by 28, and 8,827 divided by 97. So I'm going to do 3 separate lists of multiples of those 2 numbers that I'm dividing by. So the first one I'm going to do, and the best way to do this is by using partitioning. It's the most accurate way of doing it because I found that most of the mistakes made in long division are generating the list of multiples. If you can get your list of multiples correct, then everything else takes care of itself. So the first one I'm going to find is the list of multiples of the number 37. So I write that at the top. I'm now going to partition that into its tens number. The first multiple of 10 is 30, and its sevens number. So it's tens and its units. And this is going to give me my first multiple of 37, which is 37. 30 plus 7 is 37. Okay, now I could do this one by one. So my second multiple is going to be 30, 60 plus 7, 14 equals 74. But now I can see that I can get a pattern going, so it might be quicker. Now, usually I do about 5 or 6 of the multiples, but I could go all the way up to 9 times 37 if I wish to. So 3, 6, 9, the 30 times table is just the 3 times table, but 10 times bigger. So 3, 6, 9, 30, 60, 90, 120, 150, 180, 3, 6, 9, 12, 15, 18, 21, so 210, 24, so 240, 27, so 270. So that's going to give me the 3rd, 4th, 5th, 6th, 7th, 8th, 9th multiple of 37. And now I do the same on the right with my 7 times table because that's my unit. 7, 14, 21, 28, 35, 42, 49, 56, 63. And the next tip is to then add those 2 together. Now, because we've got a nice number in the tens, there's always a multiple of 10. It's a lot easier to mentally add these numbers together. So 90 and 21 is 111. 120 and 28 is 148, 185, 222, 259, 296, 333. And I'll use these in my long division. Next one we'll do, I've prepared the grid already. So I'm going to do multiples of 28. So again, I'm going to do my 20 times table on this side and my 8 times table on that side. So 20, 40, 60, 80, 100, 120, 140, 160, 180. My 8 times table, 8, 16, 24, 32, 40, 48, 56, 64, and 72. And finally, I add these together to get my first multiple of 28 is 28, 56, that's 2 lots of 28, 84, 112, 140, 168, 196, 224, and 252. Okay, they're nice and simple because I can add these mentally a lot easier than if I was trying to count up in 28s either in my head or just using listing them just as they are. This is where the mistakes are made sometimes when we're trying to add these 28 onto each of these numbers to create our list of multiples. Mistakes are made there. Now, the good thing about this is that if a mistake is made when adding up one or two of these mentally, then the mistake could be made there, but actually it's more likely that the rest of the multiples will be correct if you add those up correctly. Final one. So now a big number, 97, multiples of 97. So again, we're going to partition, we're going to split these into the 90s and the 7s. So for the 90s, it's just my 9 times table, but 10 times bigger. So 9, 18, 27, 36, 45, 54, 63, 72, and 81. But these are going to be 10 times bigger because it's the 90 times table, so I can just make them all 10 times bigger. And 60, 450, 540, 630, 720, 810. Now for the 7 times table, this is just 7 because it's 7 units, 7 ones. So 7, 14, 21, 28, 35, 42, 49, 56, and 63. So the last step to do is now combine these together by adding to get each multiple of 97. So 97, 194. It's nice and easy. I can add the 10 and the 4 to make 194. 270, 80, 91. 360, 370, 388. 450 and 35 is 85. 540 and 42, 582. 630 and 49 is 79. 700 and 20 and 56, 776. And finally 810 and 63 is 873. Now go and look at the long division video to see how I'm going to use these multiples to get those answers correct.